My name is Pramod Varma, and I was the chief architect for Aadhaar. I have with me Rakhu, who's been a principal architect at when we did the project at Aadhaar. We are going to talk about more of the technology aspects today. It's a very long topic, and it's one of the largest projects in the world, and largest identity system, going to be largest identity system in the world. And we can't talk about all the benefits and everything else today. So we will try to stick with the technology part, because that's what you guys are here for. And we can share with you how we built up the system from scratch to go to 200 million people. We have 200 million people in the database now, and it's growing fast. Do you want to just help me just go down? So I'm going to very quickly talk about, I think there is it's important that I give you a context of where we are. So we are a country with 1.2 billion people and about 6 lakhs odd villages, and very important, some of the numbers, 60% live under $2, and only 3% pays tax. So all of you are part of the privileged 3% possibly. And we have less than 20% who do anything with banking. So it's a kind of a complete disparity, you can see that. And interestingly, we have 800 million mobile connections. So that's the only thing which I think we really took off like mad, and everybody figured out. So I think we underestimated people's ability to use technology. That was a good thing. So I mean, people just use it once they see value in it. And we have another interesting thing you see is about 200, 300 million people moving around in the country, where a lot of immigrants, including a lot of us who are not necessarily from Bangalore, living here and working. It actually means that we have to constantly establish our identity. So actually, our government spends about 300,000 crores. That's whatever, 20, 40 billion dollars every year, giving direct subsidies. But all the subsidies require identity. Subsidies like salary, NRE, GA wages, Janani Suraksha Yojana for women, all kinds of pension for old age, artists, a lot of money going down. And it's like paying a set of people with not necessarily having unique identity. It's a massive money. And actually, we have a lot of, so many programs for the poor, only so much percentage, about 30–40% leaks by ghost identities and unknown identity, non-existing identities, and actually duplicate identities. It's a very common thing. And so the vision was to create a common national identity. So we don't have a common national identity across for everyone. So we have PAN card, but I talked about we only have 10% of people in the country who have PAN card. Only 3% pays tax. So it's we don't have an online thing. Election identity is the most common thing, but it's not really used as an identity card of sort. And the idea was to create a biometric back, because the purpose was to solve the uniqueness. So that's the challenge. So how do you uniquely distinguish a person from the other person? And names, address don't really help. And also, sorry, if you can go back a minute. Yeah, so also interestingly, I think the strategy was to create an identity platform. It's very critical that the program doesn't take on all the features of identity and the applications. So the applications are left to every one of you, right? Several of you writing applications in the cloud. People may be writing pension or school scholarship programs, attendance systems, everything, or a banking system, financial systems, payment systems, where it requires an identity, establishing an identity, and verifying identity all the time. We do that all the time by giving copy of PAN cards and everything else, right? So we wanted to create it with an open API. So the platform is an open platform with an API that's accessible to many applications. So if you guys start working, we still don't have the critical mass. We only have 200 million people. But once you get critical mass, you'll start seeing some of your application online may require, what's your Aadhaar number? I'll verify you online, immediately, and that becomes very valuable. Okay. So the Aadhaar system is actually broken into 2 primary modules, the application itself. One is the enrollment, which is a one-time in person's life coming to Aadhaar system of any of the touch points in the ground, giving demographics data, we have actually very minimal data. That was one of the reasons for obvious privacy and everything. It was just, purpose was only to create an identity system. And so we limited ourselves to name, date of birth, gender, and address. That's it. And optionally, we have mobile number and email. Mobile number is very common. We do see people giving mobile number. Email, we don't see at all. And we have very, very, very few people. And biometrics, so all the 10 fingers and iris. So we take both multi-model biometrics. And what we do is actually to take that request from you to give an Aadhaar number. It's a digital data, encrypted data. And we have to run through what's called a deduplication. That's really the largest challenge. Taking your identity request and running through the entire system to ensure that you are indeed unique and actually give you a new Aadhaar number if you are unique. And if you're not, we politely tell you that you are already in the system. And so you probably have a different number. And don't stand in line several times. You know, it doesn't make sense. And authentication, on the other hand, is something which you use it all the time. So once you get an Aadhaar number, when you walk into a bank, somebody walking into, today Aadhaar number is actually accepted as a bank opening KYC requirement. So know your customer requirement, and you can get a SIM card and so on. So people find it very valuable to people who have no identity, go with Aadhaar and say, I am who I am Pramod. And how does the system verify my identity claim? That's what authentication all about. So authentication is a very, very lightweight open API which can be used by applications you guys write to verify someone's identity claim. It can be on the internet, it can be on a device, it can have fingerprint, it can be OTP based. So we allow multiple things. Yeah. And yeah, go ahead, please. Thank you. And from when we actually, let me go down to technology very quickly. If your 40 minutes is very little to talk about the system, but when we started doing this together, it's the largest project, and we wanted to ensure that we, as architecture team, we put together a set of principles, design principles, by which we will design the whole system. And some of them are, one was designed for scale. Obvious reasons. We have 1.2 billion people, and you know, in February when we were doing deduplication, we had 18 crore. That's 180 million people in the database. So we were doing about 180 trillion biometric matches every day. So we had to do a lot of compute, and it's a pretty large compute, and it goes to larger database. The more compute you're going to do, because to find out you're unique or not. Of course, there are filters, smart filters you apply to reduce the matching set to a much smaller number. So the compute is still very large. And authentication, on the other hand, if even 10% of the country is authenticated every day, we are talking 100 million people, 100 million authentications every day. So 100 million API calls, and maybe 200 million, 500 million API calls. So scale was very, very important. And the next one, the next architecture principles, if you can move down once, it was open architecture. I think government project, I think it was very critical for us to bring in openness for multiple reasons. One was openness because of the, it's a very large program. We wanted to be vendor neutral, and we didn't want to use one of the proprietary technologies and so on. So we stuck with open source. So these principles were like written down, like, you know, Bible. And everything we chose, we look back and say, does it adhere to this principle? One was open standards to ensure interoperability. So we actually used almost all standards, or if you don't find, we created. So we have a bunch of standards for biometric data capture, biometric device interoperability, which in the world, nobody had done it so far, because most of the time people used to just choose a vendor and say, okay, I'm going to use your technology and go with it. So actually we had to define this API, publish it on our website, it's all on our website, where multiple developers and multiple vendors can actually, you know, comply to that API, so that we have a choice to make from. We are not stuck with one technology vendor sort of thing. And use of open source. Open source is a very, very powerful thing, and that's I think reiterated everywhere we are talking about all the talks. So it is very critical that open source gives us the power of the flexibility, openness, and actually a lot of from the security, which is the next topic. The open source also helps security a lot, especially when it's a government program. It's very, very important to know that what's going in to the system is absolutely open, and everybody, millions of developers like you are actually looking into it and ensuring that's an open system. And there's no malwares and hidden codes and anything else. It was very, very critical. And also the data security was most important for us, and it's biometric and personal data. So, entire system from capture, from the time of capture on the field, in the villages, in memory, we encrypt using PKI, and the entire system throughout the disk, it's all encrypted data. So we had some limitation in compute because we couldn't just crawl through and do text searching and things like that because it was all heavily encrypted data. But hey, we had to balance, what's security versus what's better for architecture. And data privacy. So if you move on. So, and this, on the design for scale, I want to talk about today because of big data, this particular conference about scale. And one of the architecture principles we said is we have to use scale out. So we are not going to get ourselves into the scale up architecture any place. That actually means that I'm not going to buy a component or a single database or anything. Then I expect the database to solve my computing problem. That's a bad idea. And 20 years plus I've been doing architecture. It's just not the right approach to take at all. You should say computing has to be outside the data store. So we had to make sure every pieces of the puzzle was a scale out. So we could add more nodes, we could add more servers, and we could scale. Not by buying a big box. The problem is all the annual maintenance contracts, everything else is once you buy into that, you can't get off. So it's very, very critical that you use what's called commodity hardware. So we completely run on commodity hardware. Simple Linux boxes, 64-bit, blade servers, we buy just cheap blade servers, plug it in, and the architecture actually scales. So we can actually scale up very, very, very linearly. And including the data store, I think the fourth point is very critical. A lot of application, I think Ashok just talked about that, you always see this bottleneck finally at the database side. It was very critical for us to ensure that databases by day one onwards design in the application to take care of sharding and linear scalability, horizontal scalability. And the next, move forward please. And no single point of bottleneck. It is very critical as an architect to look for and saying, if I break any of the system components, will it stop working? Will it stop working? How do I make sure that every component has redundancy? Data redundancy, compute redundancy. Two different things. A lot of people actually completely mix up with compute and data. Data stores are dummy data stores. You should use whether RDBMS, Hadoop, any data store, HBase, whatever you're using, you should be using it as a dumb store. You should actually take compute out. That actually makes it easy because that way you are not expecting database to solve through SQL all your business problems. You're building it from your principal point of view, building it from scratch outside. And things fail. I think it's very, very important that we will reiterate 100 times. Everything fails. Everything fails from software when it goes production. From blade servers, we have few thousand blade servers, for 20,000 cores plus. It just burns. So servers burn, storage die. So you have to expect failure. So how do you architect components that is built to fail? Not built to fail, built to handle failure. Okay, so built to handle failure from outside. So that is something which an application has to handle. You cannot expect somehow your vendor or a product to give you failure handling. It's a bad idea to even think of that way. And asynchronous processing. Just separate as much as possible through multiple steps of repeatable, retriable pieces of the puzzle. And idempotency, I think Ashok talked about idempotency. It's very key. All our components are built as idempotent. That means if it fails, no problem. We can start from where we left, we can retry, and you do compensating transactions and so on. So you compensate if something has gone wrong. So that's I handled in the application level. And just to give you a volume before I hand over to Reku, the volumes we are talking about, our target goal was 600, 800 million UIDs or Aadhaar numbers in 4 years. We are pretty smoothly cruising towards that. We wanted to hit 1 million a day, and within a year, so we hit 1 million. So from October last year, we have been actually doing 1 million enrollments a day into the database. So every day we get 1 million people to process and give Aadhaar number. And as the database goes up, the compute keeps going up. So we had to continue to scale without architectural rewrite. That was very critical. And in February, March time, we were doing about 200 trillion biometric matches every day. And interestingly, each of the enrollment packet we get, it's 5 megabytes. So because of biometric and it's encrypted, so it's actually 5 megabytes with lots of metadata. So the size was very, very tricky for us. Even on the villages, right? You're collecting this data in villages, and you had to transport that much of data, and it was not an online transfer. You can't put a data card and expect, hundreds of people on 5 MB every day to come into our data center. Just not have the connectivity of that large scale. So we had to do all kinds of offline data collection mechanism, but still ensuring security. So the data is heavily encrypted, signed, and so on, but it takes time to get to us. And we get about 1 million a day means, 5 terabytes. That's what incremental data we get. And every day we process about 30 terabyte of I/O in the data center today. That's what we do. And of course, lifecycle updates, address changes as you grow, and that continues forever. And new births probably will continue forever. I think I think we might peak our population, but I think new births we have about 70,000 births a day or something like that. Okay, and additional process data. We have lots of process data. Our architecture, we were extremely high on metadata. So we collected so much of metadata about the system from the enrollment. So we knew which operator is doing what, which operator spent how much time on what part of the screen, on every time, on villages, by people, by machines. We knew how much. So all that process data, and it's lovely for people who love data. It's like awesome because it has no personal data. It is just process data, knowing how many people tend to correct their name several times, and how many people spend a lot of time in the demographic field versus biometric capture. Everything is captured, and we could measure them, and we give continuous feedback through our portal to our operators. So every operator knows how they are doing in comparison with other operators, and it was and actually helps. The moment you tell people that how you are doing with other people, natural. I think people tend to improve themselves by knowing it. And go on. And authentication, on the other hand, is a very tricky thing. Very different problems. Okay, enrollment is a large file, 5 MB encrypted data, comparing with everyone to find the duplicate, whereas, and that's a throughput problem because people are not waiting. By the way, we don't give real-time Aadhaar numbers. So we collect the data, several days later you get kind of Aadhaar, right? Sometimes you have delays and all that thing. So it's a batch kind of a throughput problem. Authentication is a yes or no live call. So that is the online service we have offered to authentication user agencies such as banks, and they can subscribe to that service. And when the resident comes and say, I am Pramod, and I put my fingerprint, its system can tell you, yeah, that resident's claim of identity claim is right. You can never ask what's Pramod's address. I mean, there's only a yes or no. So if Pramod claims I live in Bangalore, you can verify. The bank can verify. It's a one-way verification. And that's a sub-second problem. We have to respond in sub-seconds. And we are currently sized for 100 million authentications a day. And all of them require guaranteed audit. So that was a little tricky for us, that the system had to do a write commit, guaranteed writes of that volume. And because the non-repudiability, you can't go back and say I didn't authenticate. So we needed digital signature. Our API is out there. You can actually look at it. We have at least few thousand developers developing applications based on these APIs. We have a Google group to discuss and all that thing. And it's very tricky to get guaranteed audits there. So we had to, and it is multi-DC architecture. That actually means that if a meteor strikes on one of the data center, you still had to guarantee the data is in the other data center. So you had to do a near data center data preservation of audit and so on. So he'll talk about part of that, how we implement it. And size is very small. Authentication requires, unlike enrollment, it's only 4K, including the digital signature. So very small, very lightweight, stateless. It's very critical that we did stateless because we could load balance across data centers, any data centers. But because of the volume, the number of audit records just grows crazy. And so we need to do mechanism to actually ensure that our data structures are allowing that. And we also have analytics. The entire system has all the metadata I talked about goes into our analytics module on Hive. We'll talk about some of that. And that Hadoop system, which is actually doing analytics, has no personal data. It's completely anonymized data going into analytics, but we get summary data. You know how many people in that age group actually are doing authentication and so on. So we understand summary level measures. Okay, yeah, go ahead. And these are the open APIs we had done. Core authentication API, best finger detection API, one-time PIN, OTP. So if you are on the internet, you don't have to use biometric. You can use one-time PIN if you have a mobile in the system. And biometric device APIs, and biometric SDK APIs, and so on. So these are all APIs which are published on our website, and a lot of developers working on it. I'll let Reku go talk to you about some of the implementation, and we'll come back and conclude. All right? Thanks. Yeah, I'll you want to take that?
Okay, so I'll try to translate some of what we discussed as principles to running code, and in that I would try to make it relevant so that each of you can take back what learnings we had and hopefully assign or try to apply some of these to programming patterns and challenges that you face. So if you see from principles, right, so on the enrollment and the authentication side, if you translate that to kind of workloads, the enrollment is a kind of asynchronous, very batch-oriented workload where no user is waiting on it. On the other hand, the authentication is a kind of a workload where someone is waiting for it. So it's a very synchronous workload. Now, you take these workloads and then we see how to translate some of the principles that we established into patterns and map it to technologies that we can use, right? So if you take to on the principle side, so we said we wanted to have very lightweight application development, so which is plain old Java objects. So we wanted to write each of our components as plain classes and be able to manage and run them. Lightweight custom application container. Now, the workloads that we had and the kind of system that we were trying to build did not fit any of the conventional enterprise applications, and contrary to what many of the vendors were trying to sell these big app servers, we decided to build our application containers to be very lightweight and custom build them. So with respect to choice of technology, so we said, hey, we don't need even J2EE. So we picked Java, but we said we don't need J2EE, so we would build our servers using the Java 2 standard edition. And to manage the runtime, we said we would use Spring. Okay. So when we also needed HTTP gateway. So if you take the authentication API, the last mail is on HTTP. So we wanted an HTTP gateway, and we had multiple choices. So we picked one, which was Tomcat. Compute patterns, again here we decided we had to move away from the conventional, the design patterns that are there of saying that typically you take data and move it into the application layer. Instead, we saw it would be relevant to move compute to the data layer. So data locality patterns, and also to be able to distribute compute across a number of machines, and here make a choice or give the ability to say, is it cheaper to move processing, or is it cheaper to move data? Okay. So in order to distribute compute across processes and within a process, we used compute architectures like SEDA, which stands for Stage Driven Architecture, and here we used a combination of Mule and RabbitMQ. Okay, where RabbitMQ gives us the the messaging layer, and Mule gives us a programming model which allows us to sequence a number of steps across machines, or to run multiple of these steps in parallel within the same JVM process. Okay, master worker. Now, while Hadoop gives us, if you take raw storage, gives us ability to do master worker, and you know, the job tracker and task tracker setup, it also suffers from high latencies, right? Because it's constantly writing data, intermediate data to the disk, shuffling data, and then use between the map and reduce phases. But for workloads like the authentication workload, where our total response time had to be in the order of milliseconds, we could not afford this latency. So we wanted another master worker pattern which was not very disk and IO bound, and for which we used grid gain. So data access types. So we had different kinds of data access patterns, or data access needs, if you were to call it. The first was high throughput streaming read, right? So when you're doing the deduplication process, so 4 terabytes of data coming into the system, being read about 4 to 5 times in a day, so it's about 25 or 30 terabytes of IO per day. So that's very high throughput streaming, which is used in BioDedup and in the analytics side of a system. So where we used HDFS, and for the analytics we use Hive. The other is high volume, moderate latency, which is like the workflow. So if you take the enrollment, it goes through a number of stages, and we kind of checkpoint intermediate stage, and then the data post Aadhaar generation goes into a store, a data store, which is ACID compliant, reliable, durable, you know, gives you the transactionality. So we use MySQL for that, and cases where we use for authentication, we kind of use a cache database that's built on HBase. The next category is very high volume, very low latency. These are needs like authentication, demographic dedupe, where you have the ability to, as an additional step in the process, dedupe a resident based on key demographic information, provide search capability, and also KYC kind of an API, and that's built on top of MongoDB as a data store, and Solr for storing secondary indexes. Now I'll just pause a minute here just to give you a dump of, so that you can digest the fact, the various technologies and what they were mapped to and what purpose they were actually chosen for. So if you have any questions here, we can take before I move further. Okay, there's the question. Okay, we did a benchmark of 10 million authentication requests in 10 hours. So 1 million an hour. So this, like I said, yeah. So so when I said that was a benchmark, so the live coming in is a few thousands, because the focus, right? If you see the lot of focus on the enrollment side, which is 200 million, so authentication systems are picking up. Okay. Okay,
Can
so
you please
personal
just repeat
information.
the question? Can you just repeat the question?
Sorry?
Just repeat his question.
Yeah, so the question he asked was, where is personal information stored, correct? Right. So the master data, like Pramod said, is encrypted and it is stored on the file system. Okay. Extracts, the demographic extracts of it, and the UID record is stored in a MySQL database. So if you say the UID data post Aadhaar generated record, that's stored in MySQL. We'll move on. Okay, so one of the challenges aside of compute that we faced was about various data stores and the kind of data consistency challenges that we have, right? So if you take the enrollment packet, so which are it's about 5 MB in size, during the time that's being processed, there is a requirement for very high throughput, read throughput, and streaming rights. And subsequent to it, we need to archive this data for 7 years. And systems like Hadoop, the challenge is you also dedicate a lot of compute associated with storage. So when we sized it, in order to store a petabyte of data in archive, we would probably need about 200 servers, and we couldn't afford to deploy so much of compute for data which is rarely going to be read. So we had to create an archive store, and the archive store is on NFS, giving moderate read throughput, pretty high latency read, right? The next, for in-process or hot data, the data is stored in HDFS. So that gives us high read throughput, also but at a cost of latency. But on top of HDFS, again, for selective data like biometric templates, we store it in HBase, so which can give us high read throughput, but at acceptable latency. And then the MySQL data store, our own experience says that it's not a debate between NoSQL versus SQL or relational versus unstructured. We have had multiple instances of data loss possible from the NoSQL stores, even though they claim to have multiple copies. So if there was one store that we could trust the data, and there is two pieces of data that we cannot afford to lose. One is the raw packet, which we store in the NFS, and the other is the Aadhaar record after it has been generated. So this Aadhaar record, along with a number of other information like address and things like that, is stored in MySQL. I mean, any RDBMS would have been fine, but use MySQL. So relatively low latency for index reads, very importantly giving us ACID properties for storing the data. Yeah, Mongo, we use it for search and other characteristics over, again, lower latency, and Solar, again, for giving us fast access. So in all of this, if you see, while we did create multiple data stores, we deal with the data consistency issues, right? What could be live in your, not in an NFS, but maybe in MySQL with respect to status of an enrollment may not necessarily be immediately reflected in the Mongo layer. So that's something to watch out for. On the architecture side, so like I said, two distinct workloads. Enrollment side, using SEDA messaging, giving us ability to scale across a number of nodes. We maintain soft state, and that soft state is very relevant for us to enable recovery. So it means any node could go down, and when it comes back, it could go and retry those transactions, supported through idempotency. Authentication side, essentially an HTTP gateway, lots more simpler from a workload standpoint, but giving us, I mean, where we had to provide for low latency processing. So in this, what we also did is all the systems are continuously emitting a lot of interesting events. And these events could be monitoring events, could be BI events. And we take these events and deliver them to relevant data stores. You will see that our entire analytics data is fed through these events which are emitted by the system. And the same events are also used for real-time monitoring of the system, which takes me to my next slide. So in order to operationalize all of this, now this is a live screen grab of, the live screen grab of the NOC, the operations monitoring, the NOC tool or the Network Operations Center. We have this SLA monitoring dashboard, which tells us what does it take for the system to continue to do 1 million Aadhaars a day. And now the system behind this, so you're talking about 20,000 cores, right? But at a business SLA level, we want to be doing, if you see the right corner there, you see like on that day it was doing 5,74,000 Aadhaar generated till that point in time, the kind of throughput that's happening, the various stages that are there in the queue, and where the various bottlenecks are. So the point I want to leave behind is all this big data is nice, but in order to operationalize them, you really need monitoring systems, right? And you can't throw people at solving this issue, but at least to see the health of your system, you really need these large monitoring systems. So for learnings, I'll give it to Pramod.
So just a quick summary slide. Pretty much learning is that, again, as he said, it's not a NoSQL, SQL. I think it's a a wrong way to argue about. I think there is a purpose for each of them. You have to choose the technology for the purpose of it, and you have to understand what the value is coming from. And the maturity cycles are maturity curves where they are very different. So we have had some bad experiences losing data and all that thing, but it's very critical that you choose data stores especially that are knowing what the flaws are. And then you can work around it, no issue at all. Actually, you can work around the flaws of HBase or Hadoop and actually do it in the application layer and recovery and any retries and so on. You get the great scale, no problem at all. But some data you can't. So some of that learning is very critical, and we want to just walk through a few things we could pick. There are a lot more maybe. One of them is make API based. I think it's obvious to a lot of developers, but when we write it, it's very tricky, or we don't know what we are writing. So write everything as components, because some things we rewrite, we probably rewrote 4 or 5 times, I think. We throw away and write. So problem was the regression, right? You had to make sure that everything is small, componentized, write an API, write test suite for that API, knowingly that you'll rewrite multiple times, okay? And everything fails. I mean, this is an experience, and even Hadoop, doesn't matter what you choose. Everything fails, MySQL come down, blade servers burn, storage all just scraps out all over the place. And it's, when you large compute, thousands of machines, and we have 2.5 petabytes of data already, it's just bound to happen. And the question you're asked as an application developer is that, do you depend on some technology to somehow recover your data? And probably not. That's a bad idea. So you have to plan for that advance. So architecturally, you have to think through, system must recover, retry transactions, sort of self-heal, and start thinking, building that way. And security and privacy, it's not an afterthought, especially for us. I think this project called for very heavily, and a lot of you guys probably building cloud services with resident data. I think you will reach a situation where you know, the government rules and the compliance and all that thing will come in, and you have to think about it from day one, okay? And scalability does not come from one product. Scalability does not come free either. I think you have to think about it. Every component you write, you have to think about how you're going to write, how you're going to scale. And the good thing is that a lot of technologies in the open source available today to make your life a lot easier. So I think that is much better 10, 15 years ago, but you have to still think about how you're going to architect. Open scalar, I think if you assume homogeneity, and if you assume that everything is come from one product or one vendor, and then you have a problem. So you have to think that everything is going to be heterogeneous. You're going to have a bunch of all kinds of technologies in it. Then the question is, how do you interoperate them? Make it interoperable, and knowingly, and using commodity computing. So if you are on the cloud, you're already on a commodity computing. And for us, we were not on the public cloud. We are on a private cloud, on our own data center. So we had to choose something which is assuming that we get best product from the market at any time. So that actually means that we don't assume any vendors, any product at all. We buy cheapest available at that time. Okay? I think that's pretty much it. So thank you so much. I don't know whether we have time for questions, especially if you're not hungry. Because it's lunchtime, right? Yeah.
Hi. So you mentioned that the amount of data that's being stored is about 5 MB, and that the API lookups are only 4K. So if I'm doing like a retina scan, how do you get that data? And
oh yeah, that's how biometrics work. What happens is the biometric images, which are captured for your finger, so the whole 10, 4 finger, 4 finger, and thumbs. Those are images. They are high quality, very heavy images. The biometric system converts them into a unique kind of a signature.
Okay.
It's called a minutia. So you convert into a minutia, and then you store the minutia. So minutia are much smaller.
So that goes in MySQL?
No, actually, no. So minutia we extract. See, the actual data is encrypted and stored. Minutia is extractable anytime. So what we do is, it's used only for authentication when you do biometric matches. So it goes in during deduplication, it goes into deduplication engine's database, but authentication is on HBase. So we have, and authentication is always based on your Aadhaar number. So our authentication API, Aadhaar number is mandatory field. That's like a 1:1 match. So you go and say, my Aadhaar number is this, and I am Pramod. So I can put my fingerprint and verify my claim.
I had one other question. So what did you guys do in terms of like, how did you think through stuff like identity theft? And you know, because knowing how the security stuff works, you know, it's obviously important. So I was just wondering what you guys did to.
There are, I mean, obviously, I'm not sure whether we can chat during the lunch too if you want, but there are a lot of aspects about the biometric itself, the fuzzy matching and how biometric, multimodal biometric helps towards that, as well as a constant fraud detection engine. So you have to we run a fraud detection behind the scene using we have an inline fraud detection as well as offline. So we actually run that constantly to figure out, but interestingly, we don't actually, in our countries, maybe, so far, different pattern of people. I think we see trivial duplicates most of the time, because you start a counter, everybody stands in line, and then you start another enrollment center, same guys stand in line again, because they think there's some government stuff going on. I don't want to miss out. Every one of my friends standing around, so I'm standing. So we see what's called a trivial duplicates, not necessarily trying to beat the system. Okay, but that might come in the future, though. As it evolves, it might come. So, but it's an evolving thing. So you have to constantly catch up with that, I think.
Yeah, my question is related to the enrollment. First thing you talked about the biometric data. So here I wanted to know the percentage of failure, occurrence of failure. And second thing, exactly how are you defining this failure? As you just said, you're taking the respective thumbprints and eye scans. And say out of this, even if one of the images, because I do have read about this in the newspaper where they had said at certain level some of the images were not printed correctly or that was not taken. So the entire account would have been considered as a failure, or how was it?
Okay, so I think I definitely don't have time to talk about a lot of biometrics, but the good thing, to answer your question, we have a white paper published on our website, uida.gov.in. It's called Use of Biometrics in Aadhaar System. Very detailed. It tells you exactly how we're using it, what are the accuracy numbers we are getting it, and how are you doing what's called a failure to capture, which is what you talked about. So we have failure to capture, how are we handling failure to capture. The multimodality helps towards that, iris and fingerprint, so one of them we can deduplicate if other one is not there. We have people with no fingers, for example, right? We have to deal with all that thing. And the idea is to not have enrollment, we have to, the goal of the system is inclusion. So we have to give identity to everyone, even if it means exception processing. So do read through that white paper. Okay, there's a lot more biometric details there. Maybe last question, I think, before. Yeah.
Yeah. So I wanted to know a little more around the deployment monitoring system.
Yeah.
Yeah. So because we are doing recommendation engine for early job seekers in India. So if you just imagine the number of people who graduate every year and seeking job opportunities right out of college. So that's the scale which we are looking at, and recently we have started growing exponentially, and I realized that deployment monitoring is one crucial factor to determine the health of your system. So I'd like to know more around the deployment monitoring infrastructure you guys are using.
Requirement monitoring?
Deployment.
Deployment monitoring.
Yes.
Yeah, that's a very good question. Yeah, I think if he talked about that. Assuming that if you as an application developer, if you assume your operators who are 24/7 monitoring your system are intelligent enough to deal with your application, you're wrong. Actually, it just can't work. So the system has to push it out very, very, very quickly, and then what's going on, and try to not even expect the people to fix that issue. I think a lot of times we have done every one of our component, for example, if it fails, completely retries by itself. So there is no need for anyone to really lose sleep over unless it's repeatedly failing. Okay. So what we did was on the network monitoring side, we use the screen you saw is actually built on HTML5. Very simple, browser based. What we do is from the application nodes, we have what's called an in-memory event collector. So we wrote ourselves a code. We didn't use any technology. Actually, we had a pattern. In fact, we'll be publishing some of that very soon. So what we did is collect all the events in memory, and we knowingly that it's okay to lose few events, and the in-memory collector kind of a singleton pattern for every node. It published onto a dashboard server. So we had a REST API which we built, a dashboard server. So on the side, this was actually collecting the data. And the monitoring, this refreshed off that REST API server. We use Nagios. We use Nagios for infrastructure monitoring. So Nagios is used for infrastructure monitoring. But if you look at this, a business guy, our CEO or our chairman, Nandan Nilekani, can walk in and say exactly what's going on. No technology involved in this, in the sense that the way you articulated this is actually completely a business person's view. So we have reviews right on in front of this saying that how come we have a so low rate. Every terminology used here in the screen, for example, are completely non-technology terminology, the business terminology. How many enrollments, how many held, how many didn't held, and all that thing. And each of those boxes can be, opened up. So this had to be custom built. We use Nagios for all the standard infra, like network components, MySQL, of course we use that. Yeah. We use
so
Nagios.
what's your availability target for the system?
Who's asking?
What's your availability target for the system?
Availability target for authentication is actually 4 nines and probably going towards 5 nines, but we are around maybe 98% of time on authentication. Enrollment is actually, because it's a batch-oriented system, we have a little more of a luxury there. So, the system can come up, go down, but as long as we get a throughput of 1 million a day, we don't have any backlog. That's all we care. So I think that's probably around 96, 97%. Yeah.
So,
okay, I think you had to hold the mic.
Over the next couple of years, you can expect that we'll have better technologies to handle many things. How will those get plugged in, or how will the system evolve?
So I think that actually goes back to my earlier saying that, first of all, we have tried to build everything as a component. Very, very, very simple, mostly API based. Even if we didn't have an API, we wrote a persistence layer. For example, you can catch up with him during lunch. We wrote a persistence layer which actually completely transparently allowed us to shift from MySQL to Mongo without any code change. So we think, at least all the experience we have, we believe that we have done it in a very small, loosely coupled, component fashion, so that we can rewrite components of the thing and evolve. It's very tricky. It's very tricky to leave it open because we have to solve a business problem today. So we have to kind of completeness is required, but loose coupling and API probably the two things you can keep in mind, I think.
Hi. If a person dies, how long the data will be retained, or how the process of...
The current policy is to retain forever.
So the data after 100 years it will be huge, right?
Yeah, we don't know 100 years later what the policy is going to be, but for now it's only small data. 1 billion is not big number. I think you guys are all talking big data, so 1 billion nobody seems to be blinking these days. So we'll keep it. Supposedly world's population peaks at 11 billion or something, so it's not so bad. Yeah, all right. Yeah, but we'll probably figure out 50 years later. It'd be good to watch.
I think
last one. No. Actually, see, it's very important. Our purpose was very, 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 very minimalistic. It was extremely important to keep it damn simple to get a system right. And that actually means that we don't want to know your relationship, whether you're married, how many wives you have, or we don't care about any of that, right? We care about you as an individual identity. You are authenticatable. Applications, on the other hand, in the system, like your banking application, they care. Your healthcare applications, those applications will care. Identity system, we don't have to know for now, but we do have a thing where somebody can report death. No, but our death reporting in this country is not clean at all. So I think it'll have to evolve a little. For now, we just mark if it's dead reported and it gets authenticated, we just know. No, actually we don't think so. We don't think cutting down the number of database records is going to make any difference, because the architecture is such a way that very little difference between a key lookup. So we are doing a completely key lookup, right? So very little difference. So we are not losing sleep over it. Let me put it that way. Yeah.
One question.
Yeah. All right.
What are the types of private usage of this information? Obviously, government agencies will be using it.
Yeah.
But what are the private?
No, actually, we have. So I think I really encourage you to visit UID or gov.in. We have some nice white paper about articulating the usage. For example, career site he talked about, or HR systems. At the end of the day, it's identity. And Aadhaar number should be considered like a root identity. So when you're born, you get an identity, and every other identity are what's called a derived identity. So your PAN card system provides you an identity for a domain, or a driver's license provides you a derived identity. Today we have nothing which is unifying them, and hence the problem with complete duplication, fake, everything else, right? So Aadhaar is not necessarily, it's just an identity, use for as a root identity that other identities can work well. So you can actually think of any system. Today, you walk in, school admission, school programs, pension programs, anything, requiring constantly, people have to claim, and you have to prove who you are. And that's a constant problem. And with immigrant labor, the 300 million people who are moving around, people they never walk alone in the road and all that, because it's very tricky for them. They can't establish their identity. So they always move in, they get caught by police and all that. It's not so identity is a very simple, who you are, that's it. And that's all we do. Actually, by the way, this system knows zero knowledge of transactions you conduct in life. So it's a zero knowledge transaction. All we do is identity, and we can verify online. Very simple. All right? Thank you.
Thank you, Pramod. Thank you, Raghunath.